Thank you very much. Good afternoon, everyone. Appreciate your coming to my presentation. So the title of my talk is Designing Through the Magical Lens of Real-Time Tools. My name is Fang. I currently work for Foster & Partners. By the way, my first name is Fang, actually. Fan or Fang, either way. So today my talk roughly divides into three parts. I think I should state there two kind of micros. First, I'm going to talk about how humans perceive the 3D environment. Second, I'm going to make a bold argument about why I believe that the current design tools are actually alienating our designers from getting an understanding of how human beings naturally perceive the environment. And finally, referring to two Unreal Engine projects I did, I will talk about the opportunities real-time technologies can bring to architecture design and research activities. All right, here we go. First of all, according to James Gibson, he's an influential psychologist who actually investigates human environmental perception. He explained that we human beings can perceive and understand the three-dimensional world through our two-dimensional retinas because of some very common yet very essential condition. The first condition is we almost always can have access to extensive gradient of texture of the ground plane laying in front of eyes. The texture is composed of repetitive elements, so offering a good reference of the depths of the space. The second condition is we're always in motion. That means our location in the world is in constant change. And according to Professor Gibson, that also enhance our ability to comprehend the environment. At a microscopic level, our brains must pick up angular disparities of incoming light signals, project to our retinas, and then our brains can process information and then to generate a sensations of depths. So there are two different means for this kind of angular disparity on retina projection to generate. First is binocular disparity, or stereopsis, and secondly is motion parallax. So the former requires two eyes observing the same object. Second is you've got to move in space. And we got those experiences quite common, actually. According to Professor Gibson, actually the motion part is more important, actually. In some very extreme conditions, people without binocular vision can still actually understand the 3D environment. Any Gunners fan here? So introducing Dean Shells, a former gunner. He has been blind in one of his eyes since 8 years old, but he made it to be a Premier League footballer. I bet he runs a lot, actually, so he can get a 3D vision. So many well-known so-called illusion or optical illusions actually utilize or exploit our dependencies on gradient of texture and dynamic vision. So this is the famous so-called Amos room illusion. You can only get the illusion when you observe this environment from fixed viewing position without moving around everything. If you can move from a different angle, this illusion just quickly dissipates. On the other hand, to give our impression of spatial depths, architecture visualizers who actually create those static renderings would try everything. They would make use of this texture gradient, and they would adopt various graphic techniques like overlapping. For example, one object is on top of the other, a volumetric fog, lens blur, etc., just to create this illusion of depths. However, according to my own professional and teaching experiences for the past 15 years, I found, unfortunately, those kind of means or techniques or situations that help us to understand 3D world better are more or less absent in our common design tools. And let me explain that. One thing that is always missing is a simple gradient of the ground plane. So when we start a project, design tools, first we're trapped in this infinite emptiness of eternity without any clues of depths. And you may use a grid pattern as a reference, but then when the object forms start to accumulate, when you using this most common shaded mode, the texture is not there. So it's always a little bit hard for us to comprehend the actual distance in depth. Moreover, it is somewhat actually inconvenient to get dynamic viewing experiences when working with those 3D applications. I don't know if that's such a UX design is intentional or whatever, but you have to do mouse drag, which means you have to press and hold a mouse button for over a second and move the mouse at the same time to rotate, to orbit, to look around, to get those dynamic views. Actually, this is actually not a very convenient way to get those views. Basically, it makes you feel less motivated to do the actions. And also, it's almost impossible to get the dynamic views and at the same time to adapt your design. Okay. So to engage those deficiencies, I believe that are important for architects to develop an appreciation of how our human beings actually understand the world. I start to develop some homemade design tools in Unreal Engine. Next, I'm going to demonstrate how this is called Project Fission, and how this project is making attempts to change the way architects or architecture designers create 3D forms. So basically, Fission is modeled after first-person computer games. It features a pure 3D environments without any 2D viewpoints. Simple mouse moves and the direction key inputs will give you convenient access to all kinds of dynamic views. The basic modeling units are solids. There's no 2D elements for you to pick or modify. And then to adjust the form, you need to use keyboard or mouse scroll. But I deliberately hide the 2D user interfaces, menus, buttons, scroll bars, all kinds of that, just because I don't want people to get this impression that you're working on 2D projection rather than the real 3D environment. Actually, 3D dynamic views are so celebrated that you got to change your sightline a little bit to pick a module. And another defining feature of this tool is you can constantly in motion, controlling the avatar, move around, and at the same time to modify the object. And I believe that feature is very important, and I'm going to continue to talk about that. So thinking about creating and modifying 3D forms in the conventional design tools, you find that you will have those hiccups, like you have to change viewports, switching from one view, parallel projection view to the perspective view, and things like that, going back and forth. And also, you have to stay still, basically. Your view cannot change when you try to modify the objects a little bit. But in Fission, you can always simulate a natural walking experiences, movement in the space. At the same time, you do rotation, you do adaptation, you do all kinds of things with simple keyboard inputs in combination with with mouse scrolls, basically. Yeah, that's kind of the actual gameplay. I call it a game, actually, but it's a design tool, and also with the genuine real-time capability of Unreal Engine, we can get all those continual adaptation of architecture forms without skipping all those intermediate. It starts to loop again. I also added some small gimmicks in the tool just to motivate people, because we have been all adapted to the conventional design tools. So if you don't do anything, stay still for a few seconds, the view will automatically start to kind of change, and you're kind of looking around involuntarily. And also, if you pick a module in distance and start to move, you'll be in this super mode, and then you can see through objects, you can sort of penetrating solid objects and move around. And when you stand still, that all those collisions will be restored, and you cannot go beyond, actually. So just a motivation. So this is a compilation of video clips of all other small features of Fission. So the developed environmental Unreal Engine actually gives me enormous flexibility to implement some features that we want to have but not available in the current design tool. Like, for example, how you can easily split it the solid into two parts and then adjust the proportion, actually. And And also, if there's a gap between those two modules, you can actually select the two of them, maintaining the gap, like this animation shows. You can maintain the gap and then adjust their locations and the proportion. Another thing is like two actions in one. You pick two modules, move them close to each other, and then merge them into one piece, like you play a Play-Doh when you're a kid, actually. So I've been thinking about those. Unreal Engine really allows me to do those things, actually, to customize how it looks. And you can save, load your designs and interoperate with regular design tools, because all parameters about those geometrical forms created in Fission are tabulated actually in a spreadsheet, and then you can use Grasshopper or Dynamo to communicate with Revit and Rhino actually to relay the geometry to these conventional design forms, and then continue on your formal exploration and everything. And this is a signature move. It's just called Fission because it's also, again, two actions in one. You first delete the object, then you create an array of its parts, and you can set up the gaps, everything. Next, I'm going to introduce another application I created. It's called Downtime Explorer. So Fission is about creating this immersive 3D modeling environment. Then Downtime Explorer is specializes in simulating pedestrians walking and seeing experiences, and give people a way to evaluate the affordance of those design spaces for positive and pleasant dynamic visual experiences. So we now don't know that dynamic vision is so important, essential to our perception of the world, but it also has a clear aesthetic dimension. Over centuries, artists would capture those glamorous moments as we move around. And in recent years, more research evidence has demonstrated that such dynamic experiences can also impact our walking behaviors. Especially in the past decade, actually, more and more architects and urban designers start to be aware if the design space cannot accommodate pleasant dynamic walking experiences, people may be discouraged to use street. They may actually just avoid using the street. They would walk less, and then make the urban environment less attractive to other people as well. So if designers really want to know how to create a favorable design dynamic visual experiences, they should actually, according to another researcher, Colin Gordon, evaluate the design space through three different dimensions. First is content, which is the fabric of the urban environment, including colors, textures, etc. Serial vision, this is a continuous visual sequence of views that people would get as they move around. And finally, place, this is the location of your body in the environment. And again, if you're in motion, all those three dimensions will constantly change. So as this computer-generated animation demonstrates extensive consistencies in content, serial vision, and place, will translate to some sort of very monotonous and depressing dynamic vision. But if you can create a strategic and poetic composition of some adaptations in serial vision, place, and content, then just like many successful street environments have demonstrated, people will be actually enjoying some very positive psychological responses such as curiosity, expectation, discoveries, which is especially true to first-time visitors. So that theory actually sounds intuitively correct and interesting, but how can we exactly measure those qualities? So basically, there are three types of data you need to collect. First, you should get lots of first-person views of the environment. And second, you need to have this ordinal sequence of those views, arrange them around a timeline about this walk people take. And then you should actually constantly measure distance between the perceiver and the elements that surround that person. We know that collecting those data are always easier said than done. So during the pre-digital age, direct collection of first-person views are almost impossible. So they actually use skill models and then those mini camcorders to do the simulation study, as you can see from this picture of Berkeley Environment Simulation Laboratory, those equipment look expensive, they are expensive, very logistically demanding. And also analyzing the data is even more kind of challenging because you have to do lots of graphic mapping and plotting and diagramming, and all the process is laborious and somewhat also unreliable. So the advent of right-angle head-mounted kind of GoPro cameras or smartphones that can record the first-person views in correspondence to your bodily position, head motion, that actually gave us some chance to directly collect those kind of data. So those are the imagery about a study I did years ago just to invite the locals to reconstruct their common walk around the city so we can take a peek about how they actually use the street environments and what they see actually along the route. And then I use some batch processing digital methods to process really voluminous of all the first-person views and organize along the timeline to understand the moments if you sort of change their views, sight lines dramatically, everything like that. But there's one issue, which is I can only collect data about the graphics. And so all the visual depths, actually, the distance thing, it is missing. And then the study part of that is not in a very rigorous way. So again, I turned to Unreal Engine and try to build my own digital simulation platform so that we can simulate someone's actual use of the environment. So this tool, the defining feature of this tool is it has a built-in digital rangefinder. And then it can actually automatically record the visual depths along several important sight lines. Depends on where people look at. And then those sight lines actually describe a visible volume that is blocked by the environment around you. And obviously, that visible volume constantly changes as you walk around and look around, as you engage the environment in different ways. If you stop, it would be stabilized a little bit. And if you continue to move around, the volume will change a little faster. So when you actually do the study, just load the design to the contest and play this game. Obviously, in the gaming mode, the overlay of this rangefinder is hidden, so you don't get distracted by that. But all the data, the numerical data, graphic data, they've been all recorded in background so that I can easily utilize them. It's a very efficient way, and I can use some sort of, for example, use Grasshopper to extract and process the data to reconstruct the routes in space. Get the sections, these are sections of the visible volumes, and align them with the moment and timeline, and also some kind of qualitative kind of assessment of their kind of visual perception as well. So there is actually actual empirical study I did, actually just compare 3 different architecture design options. The study involves 30 college students. They have never been to that site, okay? And then the design project was done by someone else, by another group of students. So they were randomly assigned to 3 experiment groups. They play the game, they load the design accordingly, and then they try to simulate a walk that would either pass by the site or traverse the site. So this diagram showing the routes people take, actually there's only one route here. So you can see that the yellow line is the directions they're looking at, and then these are the kind of the cross sections of the visible volume that I see. This it's constantly changing. Every second it's changing actually. And this chart is plotted quantitative value that synthesize and then all multiple sightline dimensions, sightline depths data to indicate the rate of change. So if the dots are higher in the y-axis, that means actually there's greater change in either in the direction people are looking at or the visible volume profile. That means actually more dramatic moments of change people would get. So the study was published in Environment and Planning B. This is a peer-reviewed journal that focuses on urban analytics. So for the career of my past few years, both Fission and Downtime Explorer have been in continued evolution. They were applied to different purposes and serve different agendas. First of all, like for Fission, it was first used as a community-based participatory design tool to involve locals in an urban revitalization project. Then as a design tool for architecture studio. And then Downtime Explorer first was used as a data collection tool for visibility studies. And after I joined Foster & Partners, I put some new thoughts about those tools. I was thinking these as exploratory sandboxes for practice, immersive design, so that we can actually chase some sustainable design values such as mental health and well-being. In terms of the fundamental 3D representation and the user experience methodology, real-time tools like Fission and Downtime Explorer, they managed that departure from the conventional 3D design tools, which unanimously emphasize the absolute geometrical conditions of fixed objects located in Cartesian space, and then they can be observed from detached away. Fission and Downtime Explorer really emphasize how people can subjectively and actively, intentionally interact with the environment, so we can have a dynamic public subject and object relationship. Probably these two alternate worldviews, I would say, they actually reflect the two different facets of architecture design. Architecture design can be understood as a human problem, which is about why we design and what architecture would do to people and to the society. And also there's an engineering facet of that, which is how you can implement a strategic sort of arrangement of physical objects and spaces, basically get a construction, get a better structure constructed. So we see that actually these two kind of above the water and below water parts should be synthesized into one platform. And that's kind of my vision about the future design tools. I would say for those CAD kind of design tools, they actually lean towards the engineering worldview. This may be because past dependence, maybe because other reasons, but that's what we observe. They lean towards the engineering worldview. And I believe that to make the idea of a real-time design tool, immersive design tool more valuable, I think we should do two more things. First is what I call data fusion, that we should actually incorporate more sources of data, not just actually first-person subjective perceptual data, but also some more objective physical data, so we can have more kind of information, and they should be organized, displayed in a very kind of smart way so that people get the message when needed. So they can stay in the driver's seat to make design decisions. Another thing that we should do more is all those real design tools, they should actually have a robust parametric linkage with BIM. BIM files are just building-centric, Cartesian representation of accurate physical structure in the world. A linkage with BIM would actually inform designer with all kinds of engineering issues that may come up in the later design stages, so that while these people focus on the comprehend and understand the human kind of implication of design, those problems about, for example, regulation, budget, structure can be forestalled actually. I have to stop here. This is my personal website, and then you can interact with me, connect with me, and then also I have to say that we are hiring. My company has a huge demand for people who can use Unreal Engine to develop and customize design tools. So if you are interested in joining the company, or if you know someone who may be potentially suitable for that kind of role, just let me know. Thank you very much.